Okay, so on this chart we have L1 or X is the month, and then we have L2, so our Y is our temperature. And when I read the info, month 1 is January, right? And then obviously month 12 would then be December. So you kind of have to understand the variables and how they're working. Okay, ready? Give me your stat edit and go. Okay. Stat edit. Everyone's good? Before I move on with sinusoidal stuff, I'm going to go to my mode. I'm going to make sure it's in radian mode for these calculator features. Okay, you have to have that radian on. Okay, steps. You know what you're doing? Y equals plot on. Yeah, Lauren.
How do you know if it needs to be radians or degrees?
Every time you do the L1, L2, radians. Okay. The only time I would ever put it in degrees is if I was graphing a given equation and my given equation would have something like this in it. Because when I see the number 45, that's not a radian number, that's a degree number. Because what's the biggest radian number in our circle? Do you remember the biggest radian number? 6.28. There's only 6.28 radians in the circle. 2 pi. 2 times 3.14. 2 pi, right? That's not a very big number. So if I ever saw something like that and I went to graph it, I would put it in degree mode before graphing. Like a 45 or 80, like something big. You know what I mean? Then I know I'm not in radians anymore. 90, whatever, yeah. Okay, so zoom 9. And then it's going kind of looking like this. Okay, so does it make sense why it's sinusoidal? Because it's also going to repeat, right? It's going to keep doing the same cycle every year. Okay, we're going to stat. We're going to calculate. And then the very bottom, right?
Wait, which one is it?
Stat calc, and then it's the very last one. Do you see it? It says sine regression. Yeah.
Is it always going to be sine?
Yep. Because it's not sine, or it's sinusoidal, and then they always just give us it in sine. Okay, when you're going to write me equations on the test, you're going to put y equals on them, right? Some of you that still are forgetting about that? Okay, so use your curve to determine the average temperature in January. So obviously I got to copy and paste it in there. Same idea. Copy paste it. I'm actually going to deactivate my plot as well. Okay. July. What do we know about July? It's our x's, and what is the x number when you're in July? 7. So I'm going to push trace 7. Trace 7 70.61 degree Fahrenheit. Is that what your calculator does? Okay, choice 7. Now, estimate when the average high temperature in Vancouver will be greater than 60 degrees. So what are we going to do there? Y2. Okay, so this is what my calculator kind of looks like. Does that make sense? So estimate when you are greater than. So I'm going to be above 60 degrees all the way from here all the way to there. That's in the zone where I'm above it, right? So I need this intersection and this intersection. And I would like you to get me the x values there. We're going to be doing months, so we can just go to 1 decimal here. So we're going to have to take it into a month language anyway. Okay, I now need you to give me an answer in words. So I'm going to get you to do an example, like I could write early February, middle of February, I could do late February. Okay, I'm going to use the words early, middle, and late to represent the month. So if you are 4.7, what month are we in? We're in April, late April to middle of September. Okay, do you see how I'm using the information, but then I have to think about the real life. What does that represent in real life? Okay, I'm going to add a question here because I want you to practice this calculator feature. My question is, how long does it take me to go through the temperature cycle? Okay. So this is my third question. How long is the cycle of this climate? Okay, I know that you're probably like, oh, it's 12 months, but let's see what our calculator does. How do we do a cycle? What's the strategy for figuring out the cycle? Which is another word, the period of the graph. What do you want to do?
Find the both bottoms or the tops.
Okay, that's one strategy. So Piper is saying, hey, let's find, for example, let's find a top, and then we'll find another top. And then what would you do with those numbers when you find those numbers? You would subtract them, right? Okay, that's one method. Are we going to do it? Let's go. I'm going to make my window larger, I guess. I'm going to go top to top. She said you could also do bottom to bottom. Doesn't matter. I guess that's up to you. What are we doing? Let's all do the same thing. Has anybody started already? Top to top? Okay, so get me a max. So this is the cycle, and I would subtract my numbers when I would have them. I got 11.4. Anybody else match that? That's after I subtracted them, right? Because you have to say, well, what's the space between those points? Okay. If anybody did the mins, that's great. If we should, did you get the same? Yeah. Okay, I'm going to show you a different way, which is going to be faster. You ready? I know this little formula. Does anybody remember it? 2 pi over b is the formula for a period of time. So here's what I'm going to do. 2 pi divided by, I'm just typing it in my calculator, 2 pi divided by, how do I get my calculator to insert the b? Do you remember how to do that feature? I'm going to copy and paste it, so that's the start. What button do you always hit for copy paste? Vars, statistics, equation, but what do you want to insert instead of the whole equation? Just the b. And what do you get? 11.4. Same thing. Does that make sense? That's what's happening. Pretty cool. Okay, let's go to number 2 again. So erase everything, stat edit, type in. Okay, L1, L2. I'm going to turn my plot on and I'm going to zoom 9. And there we go. We're going on a Ferris wheel ride. So we go, that's what we're doing on our Ferris wheel. Time and height. Okay, he went on it for 4 consecutive rotations, actually, so technically that's what you would have had, right? That's the whole thing that he did. Okay, his friend Scotty was in a building across from the Ferris wheel at a height of 400. When was Jordan level with Scotty? So what am I going to do? His friend was somewhere else looking at a building at a height of 400. I'm going to do a y2. Okay, so get your calculate. Get your equation. You should always write me an equation even if I don't ask for it. And the reason is if you do your work wrong, then I can at least follow what you're doing. Get your equation, copy and paste it. You guys know all these steps. And get me a y2. So his friend is on a building at 400. Get me a y2. Okay, here's what we're going to do. Get me the intersection right there, and that's it. I just want those 2 intersections for now. This intersection and that intersection is when his friend would be level. I'm going to yell at me if you're not matching my times. 11.85 minutes, 25.15 minutes. Okay, ready? Here's what I'm going to do. How long does it take me to go through a cycle? Can you answer that question for me? Using, I would say it's easier just to go 2 pi, divide by, and then insert the b. You can still do max to max or min to min if you need to or whatever, but this would be, for me, a little bit faster. I got 37 minutes to do the ride. Yeah. I thought isn't there one in Paris that's like an hour or something? What were you gonna ask me? Okay, so here's what I'm going to do. Would it make sense that when I'm at this point, it should be exactly 37 longer than that point? Because would it make sense that this point and this point are matches on a cycle? You know what I mean? So this point should be 37 longer. So let's get all of these points right now. So go 11.85 plus 37 plus 37 plus 37, like that. Just go on your calculator screen, just go plus 37 equals, plus 37 equals, plus 37 equals. So all these times are the times that he's going to reach his friend. And then we would just do the same strategy for this coordinate, because this coordinate is in the same rotation of the cycle. Okay? Don't forget, this is him hitting 400 on the Ferris wheel upward, and then this is him hitting it on the way down, right? And again, this is what my screen I'm doing. I'm doing plus 37, plus 37, plus 37. Okay, what does your back look like of that notes booklet? Or is it, that was the back? Is there anything that has a blank on the back? Your work booklet? A recap? Anything that has a blank? Your notes has blank? Okay. answer key. Let's go on the back of our answer key then. Do you know what a steamboat is in real life? No, or am I thinking of the wrong boat? It's like, what am I thinking of? It's a boat that has like a wheel.
Oh, wheelboat.
Wheelboat? Is that the name of it?
Obviously.
Do you guys know what I'm talking about though?
Yeah.
It's not.
A wheelboat.
Why am I blanking? Okay, a paddle boat. Because I'm trying to make you guys visualize what is happening. Or I could just Google a visual for you here. I'm not very artistic, so. No.
That's what I think of when I hear.
No, that's not what I'm thinking of.
We have one at the cabin wheel. Yeah, you do.
Down in the bush.
Like the one where you. Yeah, like that's a paddle boat. I thought it was a paddle boat.
This thing, this is what
Oh
I'm
yeah, they
thinking.
definitely have that at Disney.
This.
Don't look at me like that. Oh.
So what's the name of this one? Wheel? I don't know. I'll think of it probably after. Okay, good. You got your visualization of what's happening in real life. A boat that looks like this, whatever the name of this boat is. Okay, so I'm going to give you some criteria here. Let's say this wheel is, what do you want to do? What's the diameter of that wheel?
10 feet.
10 feet wide. So, would you understand that the radius of the wheel is 5? Now, when I'm here, when I'm there, I'm actually 4 feet under the water. Does that make sense? I'm 4 feet under the water. I made it up. Okay. What do you guys want? Make up info. How long does it take for me to go around the wheel? Whole one spin.
60 seconds.
60 seconds, a minute?
I don't know.
Let's go less than that. Let's go for 40 seconds, whatever. Okay. That's 40 seconds to go around. Okay. Ready? Make me a chart. Okay, so here's my variables. The time and the distance with the water. Distance with the water, distance to the water. Okay, ready? At a time of 0, what is our distance with the water line? -4. Now, I'm going to put a star over here. What is the time right now? It took me 40 seconds to go all the way around. 10 seconds here. I'm at 10 seconds. what's my distance with the water line? 1, yep. I'm 1 above. You see where I'm getting that from? This was 4 below. And then if you go up 5, that's how I got to a 1, right? Because the radius. Okay, now let's talk about this position on the circle. So now I'm here. What's the time of the spin right now? 20. And with regards to the water line, how high are you? You are now 6. Okay, let's put the star onto this side. What's the time you are here? 30 seconds. And would you agree you're back to +1? And then we're going to finish it off at a 40 seconds, and then we're back to -4. Would you agree I've now mapped out 1 complete cycle? Okay, so you're going to have to be able to do questions like that, where you have to get me the time intervals and you have to get me all those breakdowns. So give me a stat edit on that. Do all your steps, plot it out. Okay, that's good. Give me an equation. So stat, calculate your equation. Copy and paste. You're doing all these steps on your own, right? Everyone's good with the numbers I'm getting? Same? Okay. Here's some things I'm going to observe. Why did they put a 5 in the front there? What does that mean for you? It is the amplitude, and within a circle, what does your amplitude resemble in a circle? The radius, right? Because it's midpoint to the top, midpoint to the bottom. So that's the same. And does this look familiar, this number? What does that always represent in an equation? The mid. So that's where we are when we're in the middle. Can you test 2 pi over your B number? Can you test that out? And it should come out to be, it should be 40. So let's go to our home screen. So 2 pi divided by, copy paste the B, and it should be 40. Yep. It's telling me it takes 40 seconds to go around the cycle. Okay, here's my question. I have a sign. I put a sign right there on like a sticker print. I put a sticker print out on the wheel right at the bottom. Okay. How long is it visible to people above the water? That's my question for you. If I put a sign there, how long would it stay visible out of the water? So what are you going to do? You're going to understand that this part of the graph is where it would be visible. So I need to find those, which I heard was calculating the zeros this time. Okay, now, how long? How long? How do you answer that? What would I do with these numbers? I have them both. Subtract them. So, any point on this wheel would spend exactly 22.56 seconds out of the water. Quickly, if I wanted to ever see how long they're out in the water, that would be 17.44 seconds that they're under on a cycle. Every cycle they spend that out, 17.44 in. Okay, that's it.